Hello, everyone. Welcome to Encora Chats. My name is Madhura. Thank you for joining our live fireside chat. Our topic for today is reimagining grid efficiency and sustainability with digital twin technology. Joining us to share knowledge and expertise on this topic are Subhash Sivakumaran, Senior Vice President, Energy and Utilities at Encora. Subhash is a senior professional with over 25 years of experience aiding utility companies in embracing cloud and digital engineering solutions. And we have Keshav Sundaresh, Global Director of Product Management at Altair. Keshav brings in 15 years of engineering expertise along with thought leadership, strategy, and development of integrated solutions. He has worked on 100 plus deployment of digital twin projects in utilities and other sectors. Welcome on board, Subhash and Keshav. And with that, I'll pass over the mic to you.
Hey, thank you, Mother. Well, happy almost Friday, ladies and gentlemen. It's such a pleasure to be in front of you today. What Subhash and I will cover over the next few minutes are essentially three big questions. Safe harbor statement as a public company. So we want to cover essentially why digital twin is such a relevant topic in the energy and utility space. We want to show you some evidence in terms of how some of the energy and utility companies have been adopting digital twin and AI, or physics-based and data-driven digital twin techniques. And last but not the least, we want to cover a little bit about what impact does Altair and Encora bring to the table when it comes to all things digital engineering, digital twins, and AI. But before I continue down this path, Subhash, how are you doing, sir?
I'm doing really good. Good to meet you, Keshav, after a while.
Did you have a cup of coffee today, Subhash?
Yeah, I mean, I always love to have a cup of filter coffee any point of time. Strong.
Awesome.
Yeah.
Maybe I thought since this is a virtual fireside chat, Subhash, it might help if I served you some virtual coffee. So let me just go ahead and do that. Do you have a favorite coffee or tea?
I'll go with my mocha any day.
You go with your mocha every day. Okay. So unfortunately, I don't know if I have a mocha choice here, but what you're seeing in this demonstrator is a coffee machine digital twin, wherein depending on what selections you make. So for instance, if I want to brew some Americano with this machine, you can accordingly see the changes in the energy consumptions across the coffee machine model. If I go a little deeper into this model, what you'll actually see is that this is a multi-domain, a multidisciplinary system where you're essentially seeing interactions between several different domains: mechanical, electrical, thermal, controls, and so on and so forth. And this interface that you're seeing here is essentially a dynamic digital twin modeling environment, in that it goes beyond CAD and it allows you to visualize the dynamic key performance indicators of various different types of assets. Right. I just thought it would be nice to start with a coffee, Subhash, but I can also, show a couple other examples. Transformers. If you were to use, for instance, a first principles approach to simulate the behavior of transformers across multiple different types of temperature loads, resistance, and inductances, you can once again run a partial differential equation based digital twin model that would give you back, for instance, things like what's the active power between the source and the load, what's the quasi RMS current like, and so on and so forth. But for people who are not necessarily experts, quote unquote, in digital twin, you would ideally want to have a non-expert like dashboard or an environment from where you can essentially key in just the basic parameters and run these simulations behind the scenes, right? So to do that, here's another example, right? So this is a real-time visualization and dashboard, which essentially brings in the environment data from NOAA. So you're actually getting the buoy data from various different stations across the US. And so what you can do is you can just pick a station, you can specify the hub height, you can choose how many number of sample points you want to use for a simulation. You can then use this data to as an input to a digital twin quote unquote model with furthermore information in terms of just the turbine parameters itself, from blade length all the way to the rated wind speed. You can either use the default values or you can key in these values. And when you click on this run digital twin button here, what this action can do is it can trigger a a complex, if you will, a multidisciplinary system of systems model of a wind turbine, wherein it's actually reading environmental data into this system and accordingly giving you, for instance, predictions in terms of the power, predictions in terms of some of the other energy coefficients, in terms of understanding the LCOE, the levelized cost of energy, so on and so
Right.
forth.
Interesting.
Should I double click a little bit more in terms of customer examples, Subhash? What do you think?
That would be great. Customer example always resonate with people.
All right, so let me maybe show you a few more examples. So, like I mentioned, we'll cover three big questions: why, how, and what. So let's maybe start with some more customer examples. So here's a large utilities customer that we've been working with. They have historically been, a company that has had a lot of expertise when it comes to the traditional utilities sector, but over the last, I want to say, 5 to 10 years or so, they've been tasked to commission a lot of their offshore wind turbines. Now,
Okay.
their data analytics and IT practice team are not necessarily quote unquote domain experts in the power sector or in the power generation sector when it comes to offshore wind. So they outsourced a lot of the commissioning activity to third-party companies. Third-party companies typically have a very conservative maintenance schedule. So which means, utilities customers would have to essentially pay more and more to commission these systems. So one of the tasks for quote unquote digital twin that this customer, came up with was to be able to see if a digital twin can be used to virtually commission different types of mechatronic systems, in this case, an offshore wind turbine, wherein we still bring in the environmental context. We also bring in the physical product context in terms of the sensor data. But using a combination of those two with just a limited set of quote unquote OEM specifications, the idea is to be able to create an executable dynamic digital twin model that helps integrate and converge data across many different data sources. And once again, the idea behind this digital twin is to be able to virtually run a lot of what if scenarios. So
I
if
see.
there is a difference in, for instance, the wind speed, how does it impact the total power generation, for instance? So you can ask these questions directly to a digital twin model instead of having to use, the rudimentary or the basic means of going through, um, you know, what I call a trial and error process of discovering some of this information, right?
I being a utility guy, I'm just taking the liberty of asking this question from a utility perspective. You mentioned that minimize downtime. Can you briefly double click on that? How you basically help on minimizing downtime?
Yeah, sure. I mean, the very fact that you have a virtual representation of a real world asset,
Yeah.
you know and it's not just a digital shadow, meaning it's not just a static model or a CAD model, if you will, that has the point cloud or the lidar, for instance, capture of the infrastructure, but it's really about making these models more smart, intelligent, and connected, wherein at any wherein there is some fidelity for the model itself, but there is also some sort of a back and forth communication between the physical asset and this virtual model. And so think of this as the heartbeat for your physical asset, right? So as your physical asset matures or goes through its service, you have this virtual model updating constantly. And so you can ask a whole bunch of operational related questions. engineering related questions, manufacturing related questions to the virtual model and take informed decisions as opposed to having to always send operators or service technicians and once again use a brute force method to making course corrections for maintenance or other downtime related issues.
Totally agree. Thank you. Really interesting. Appreciate it.
Sure. So here's another example. So this is from a large nuclear energy customer based out of the UK. And historically, they have a research practice where they've been applying a lot of computational science techniques to understand the behavior of how an asset or how a power plant would function when it comes to deploying it in a specific set of environments. And during your as design stage of the product, you essentially develop your maintenance schedule that's based on your worst case loading condition. And sometimes the maintenance schedule that you develop using the as design basis
Yeah.
is not necessarily reflective of what's going on in the real world. So for this customer, they wanted to be able to reuse some of their computational science models or knowledge, be it physics-based models or some of the machine learning models that they had developed over time, and create this connected integrated ecosystem wherein through an IoT device they were essentially monitoring the performance status and health of the power plants, and they wanted to integrate these models along with their domain knowledge, AI, compute, and IoT together to be able to right size the maintenance, to also be able to have a holistic understanding of what their plant operations are like, right? And so this is yet another, if you will, use case or quote unquote definition of a digital twin.
Very
And
nice.
this can go past, just the physics-based view, right? So
Yeah.
there is what I call a spectrum of fidelity when it comes to digital twins. So you can either, if you don't have a lot of operational data, you can use physics-based techniques to essentially model and understand the current state and even predict the future state of equipment or infrastructure or processes. But if you have a lot of operational data available, which was the case with this large petrochemical manufacturer, they basically realized that they were spending close to $20 million a year in terms of just for electricity for some of their ethylene plants. And they had lots of data available, but also they had a lot of interdependent quote unquote operating parameters, and they were not data science experts, so to speak. So that so they wanted to rely on a no code, if you will, code optional data science environment, wherein they could equip some of these oil and gas, if you will, experts or service technicians to be able to leverage machine learning to
Right.
understand how to drive plant efficiency by doing feature engineering, by automatically deriving certain machine learning models, and so on and so forth. So for this customer, a digital twin implementation was a purely data-driven one, in that by applying no-code data science, they were able to dramatically reduce the power consumption and also dramatically save a ton of cost, operational expense due to this.
I think the sweet spot, what you touched upon, is the fact that they did not have any difficulty in seamlessly transition to the new system, right? Low code node platform. The learning curve is not very steep. So those are, I think, the biggest thing, and those are kind of things what we see as obstacles in utilities.
Right, right.
Yeah.
Yeah, and so moving further, here's yet another slightly different but an important use case, and this is around power electronics. So we currently have a partnership with several large businesses, that works with for instance, the US DoD, Department of Defense microgrid. And as you know, simulation and design of microgrids really require the use of expensive real-time hardware, um, or sometimes use of quote unquote average models. Both these approaches, regardless of whether you're doing hardware in the loop or using these lower fidelity models, both these approaches require some sort of a compromise and abstraction from the desired system. And the real-time simulation hardware is expensive. It limits things like being able to, change the switching speed, change the number of switches, machine models, so on and so forth. And the offline approach sometimes that uses average models can give you only simplified or abstract answers. For this specific customer, it used to take them close to 4.5 months, if not more, to assess their microgrid performance. And lo and behold, with our, if you will, model-based approach to digital twin, with
Yeah.
our model-based approach to power electronics, we've been able to help them simulate significantly large microgrids. Microgrids that span across 1,200 switches, 10-unit microgrids, with a cascaded, H-bridge modular multi-level converters. We were able to dramatically bring the time to results down from several days to just 2 minutes or less. So this gives I would call it disruptive shift in terms of how power electronics are being simulated, right?
Very interesting.
Just to expand on that, in my experience working with a lot of utilities and energy customers worldwide, I find that while there's obviously a modeling gap, or an importance to essentially bring together different data sources to develop newer, far greater insights through modeling, there is also a challenge in terms of having good data and good data management. So one of the things that we've been doing with a few E&U companies is to be able to enable them to be able to connect data across their enterprise, from engineering, operations to various information sources, to connect all their systems of record to having a system of intelligence that's graph based, so that you can understand the relationships, you can understand the causality, if you will, and really get down to figuring out the root cause of where issues occur and trace them, govern them as quickly as possible, right? So I strongly believe that knowledge graphs and having a semantic data platform is yet another key challenge that a lot of the E&U companies face. But Subhash, you have more experience. Maybe you can help summarize some of the other challenges that
Yeah.
seen.
Yeah, I will probably, there are multiple challenges, but I'll probably focus on four of them. The first being aging infrastructure. The infrastructure, as you know, Keshav, has become very old. Some utilities have close to 80 years old infrastructure. And do you know, right now, as we are talking, one of the major issues faced by electric utilities, what are they? You'll be very surprised. It is increasing blackout due to aging power grid. I mean, as you and me are talking, you know what happened in my state, in Texas. So many people are without power, and even now some people are without power. And you cannot blame them on the power companies because of the aging infrastructure caused by extreme weather events and not being able to rapidly deploy or transition to clean energy sources. The clean energy sources are there, power has been produced, but there's a bottleneck in accepting that power source to be integrated with smart grid. And I'm not telling this. This is the North American Electric Reliability Corporation, or NERC, which is saying this. I would like to give you some interesting facts about the aging infrastructure. Nothing like getting the facts on the table before we talk about the actual problem. NERC basically said the projected electricity demand is growing year on year in the last 10 years, and 2023 grew by 10.6%. It's been 10% year on year through 2032. But
Wow.
So this is the energy demand. On the generation side, what is happening is the expansion is just happening at 4.3% during the time is estimated. So there's a big gap between what is the power demand versus what is being generated.
Yeah.
Based on current trends, much of the central and southern parts of the United States looking very bleak. They're likely to face power shortfalls in the coming decades, even during normal weather. I'm talking not about abnormal weather like extreme heat and winter, even normal weather when the temperature goes up by like 5 degrees from 85 to 90 degrees. It's a problem. We are facing it here in Texas. I would like to draw an attention to one independent service operator, MISO. I was talking to their senior vice president of the records. So they had basically put in place a grid reliability action plan to basically do storm hardening and system hardening. And this can actually go all the way up to 2028. They bought some time. But the Midwest region is looking at a projected shortfall of 4,700 megawatts of power because of one, aging infrastructure. Second is because of the aging infrastructure, some of the power plants have to be retired. Even with the addition of 12,000 megawatts of power planned new generation, which they are planning in the Midwest region, MISO. And this is quoted by NERC actually. So this is not any off the cuff remark. And the critical period, as I see for the 6-state southeastern grid, is between 2025 and 2027, when coal-fired power plants are retired. And now you must be thinking, why am I bringing these operational business problems and presenting it to you? It could have been largely negated if they had made this entire grid what they have a completely seamless digital infrastructure and put it on a digital twin. They have not done that. Then that way they would have been able to anticipate in a much better manner the demand response system and what is the shortfall.
Right.
Tell you one other, this is an interesting thing. The US electricity consumption has grown on a record basis, and now right now in 2020, end of 2022, it's at 4.05 trillion kilowatt hour of power. This is kind of a record from, it's like 14 times more than the power we consumed from 1950. I know there is a proliferation of IoT devices, everything is connected now and all this thing, I agree. This may not seem like a revelation to many people in US, but the fact that they take it for granted because they have electric vehicles, they've got air conditioners running and all this thing. But you may be surprised to learn that much of the domestic electric infrastructure is very antiquated. And that is one of the reasons why the ability to scale is not there. And this coupled with the fact that the upgrading of infrastructure is facing a lot of delays and cost overruns. So the domestic transmission system that carries high voltage electricity from, say, power generation sources over large contiguous geographic areas, and the distribution system that links end customers of, say, low voltage electricity to the transmission system, it all from 1950s. So in 2023, Berkeley Lab concluded that they came and did a study, and they concluded the connection queue of solar and wind projects waiting to integrate into the grid total incremental capacities, surprising, 1,250 gigawatts of power. That's equivalent to the current capacity of generation of US power plants. And the queue for wind and solar, I not even talked about that. That's an additional thing. So the backlog and the need for interconnection is taking years to bring it to the central grid. That's basically taking a lot of time.
Right.
I can go on and on. So if you take the renewable energy sector, that's also another major challenge. The renewable energy sector is having more and more cars. Now people say that US is not that much forward-looking when it comes to renewable energy as a source, but over the last few decades, this has been accelerated. There are a few factors that are accelerating, and utilities are embracing renewable energy. One is, as you know, the corporate mandate for net zero. All the utilities have there in the shareholder reports. Right. Second is the factor we talked about, global warming and aging infrastructure. So naturally, it's got accelerated. Third is the geopolitical tension. People don't want to buy power from rogue nations. Fossil fuels are from independent countries, which basically put a premium. The last part is what is going to be of interest to you. The smart grid and digitalization journey of utilities has led to smart meters, which is Industry 4.0 meters, and that basically is proliferated along with the IoT devices, billions of data points. Utilities don't have an idea how to basically collect 1 million smart meter points, collecting every 15 days. That amounts to 2,900 terabytes of data per year. Wow. So there is not a unified platform which can give you a bird's eye view of the operation system and the virtual reality system. I think that's where something like a robust digital twin from an Altair 1 can play a big part for not only grid level interoperability, forecasting, bringing in visualization through GIS, operational control systems, and everything is actually combined to create a digital real-time representation of the physical infrastructure. So
Right.
renewable energy systems actually need that, and now the utilities have come around to the fact that they don't have something like a digital twin which can actually provide information which is holistic in nature. Then I'll take a stop here. If you have any questions or if you have any thoughts.
No, I mean, just to expand or drive home the point that you made initially. I
Yeah,
think in our experience, you and I have worked together with several companies together. What I've experienced personally is that the expertise when it comes to digital twin and data science
yeah,
is not necessarily democratized in a lot of the utilities and energy companies.
I agree.
There is typically a center of excellence practice that is responsible for bearing a lot of the weight when it comes to some of these up and coming initiatives. But I think where things would get really beneficial for these large enterprises is when we can help democratize the practice of digital twin and data science. Right?
Yeah,
Some of them have gone about obviously hiring lots and lots of data scientists, but the challenge is that the data scientists lack domain knowledge. They're not domain experts in power, in some of the other utility specific domains. And
yeah,
so it's important to take these domain experts and convert them also into data science experts without them having to go through a steep learning curve. Number one.
that's very important. Yeah, agree with that.
And two, the IT layer, if you will, should be light and should be managed easily, as opposed to having a large Frankenstein monster type of a setup developed for enterprises. So we spoke enough about use cases, we spoke about challenges, but
Yeah,
perhaps the audience might be wondering, what is a digital twin? I mean, as a CAD model, a digital twin is a point cloud data or LiDAR data. Is that a digital twin? In our experience, a digital twin is a living and breathing model of systems. These systems can be based on a physical process or a business process.
yeah,
Essentially, these systems are grounded in physics, not just pure statistics or not just pure quote unquote CAD. Wherein these models also assimilate data coming from the environment, from inspection, sensors, metrology, meteorology, etc. Right? And so there are really two stages or two phases to a digital twin. There is the what I call the design phase and the deployment phase. So in the design phase, there are a few key technology enablers that customers typically look for. One is if you have a lot of legacy data
yeah,
that you have in your internal systems, how can you innovate with that legacy data? So engineering data science becomes a very important pillar in that. Second is systems thinking. How can I combine or connect and define interfaces and interactions between different domains so that I can holistically understand how either a product or a product plus environment or a process or an infrastructure twin would work.
yeah,
And last is, how can I take some of these really complex, quote unquote, precision simulation models, but how can I make them efficient so that this can be used in a deployment stage when it comes to doing anomaly detection or condition monitoring or structural health monitoring to be able to predict the remaining useful life or coming up with a more accurate predictive maintenance schedule, right? So it's not this or that. In my view, it's this and that. So there are, for instance, digital twin solution providers in the market today that offer a very simulation centric view. And there are certain providers who offer a very analytics focused set of capabilities. And then there are digital twin solutions or environments out there that provide a very compute centric view. But it's the integration between simulation, high performance computing, and AI where the true integration and magic, quote unquote, happens. And so to help facilitate that entire breadth of, starting from requirements to retirement,
yeah,
we have three platforms under the Altair, under the Altair One platform. So we have Hyper works for all things precision simulation
Mhm.
across different levels of fidelity, from equations to block diagrams to 3D modeling. We have Rapid Miner, which is the leader in the Gartner Magic Quadrant. It is a no-code, code-optional data analytics, IoT, and AI platform that connects very well to the simulation models. And then to enable that scale in terms of cloud bursting across any cloud vendor of your choice, user management, file management, etc., we have HPC Works for high performance computing. But again, Subhash, like I said, having these modeling strategies and approaches are great, but you also ought to be able to manage the data and the models itself so that you add a traceable governance layer to it.
Data management is a major challenge. Agree.
So the key is to be able to link information generated from various stages of your product and your system lifecycle through a common data model or a common data driven architecture. And so to help enable that, we have a one traceable thread practice at Altair that offers various sets of technologies and consulting, obviously with Encora partner, to be able to customize, to be able to tailor the workflows to suit an enterprise's requirements. So, for instance, if an enterprise uses a specific PLM system, if they have a specific set of big data Hadoop sort of systems in place, if they have a set of RDBMS databases in-house, they have a bunch of document repositories and BI and other applications. We have a way to essentially work well with all kinds of data sources, with all kinds of platforms, as opposed to locking you into a specific vendor or forcing you to switch to our practice, right? You cited some examples, Subhash, about user personas and some of the people that you've been working with.
Yeah.
So if you look, from left to right, there are within enterprises there are people who are less technical to people who are highly technical coders, right?
Yeah. Yeah.
And so they use different kinds of interfaces for various problem solving capabilities. And the greater need is for these different users who know their job function and domain really well and who know their domain data really well to be able to self-serve and solve as much of their problem as they can in a shortened time to results way, right?
Yeah.
And so to enable this, we have the Rapid Miner platform. We have invested more than $500 million over the last decade into delivering a complete end-to-end analytics capability. So regardless of your persona and your preferred authoring modality, you're able to complete your task all the way from all the
Amazing.
way to deployment. Yeah, and so if you just expand this further, you have quote unquote an AI fabric, right? Which combines the best things about AI ML platforms along with data fabrics. It provides a code first development tools for the data team and low code and no code tools for business users. It offers connectivity, data management, data movement, data discovery, and also semantics and ontology. Right?
Yeah.
To bring everything together, it essentially helps unify the overlay for organizations from being able to integrate across unstructured, semi-structured, and structured data sources from, like I said, from RBDMS all the way down to PLM. It allows you to activate a set of strong data foundations for the enterprise. It empowers you with, giving you the right user experience for the right user persona, and it helps accelerate by delivering curated data products to the respective businesses.
Amazing.
So to put it all together, it's not just about AI or data science. It's not just about simulation, not just about HPC. It's really the integration of these three where excellence truly happens, and we have seen time and again our customers benefiting from this convergence. The convergence should not be custom logic built all the time. There needs to be a lot of out of the box solutions that should be available, and so we provide those out of the box environments through workflow enabled convergence. And so, as you worked with me and with Altair long enough to know that we work well with everyone.
Yes.
Open architecture is the name of the game. Being able to be flexible, purpose driven, and being able to work with all vendors is key to be able to take digital twin technology to practice in a frictionless manner.
Yeah.
Being able to switch between desktop, private cloud, public cloud across various cloud environments is also important. And having a distributed cloud, sort of an innovation gateway, is key for a lot of these aging infrastructure problems that you spoke about. And last but not the least, affordability. In being able to access some of these technologies without having to spend a lot of money is crucial. So we have a patented licensing that sort of brings all of these different technologies together.
I would probably put affordability as the first one, but that good that you brought up that point, because affordability is a major thing, especially if it's going to be coming from the operational expenditure budget. So that's very important. Yeah. Very good, Keshav. I'm really happy the way you provide information. I learned something new today as well. So really appreciate that.
Sure. Do you want to briefly cover the cloud first, data first, AI first,
Absolutely.
Subhash? Yeah?
The reason why I think you and me are able to work in a very cohesive manner, seamless manner on one side, the fact that the market is actually getting benefit out of our partnership is because we're very focused on digital engineering. Digital engineering is our DNA, and that combined with our deep subject matter expertise in the oil and gas and utilities basically enables us to provide not only subject matter expertise on the functional area, but also on the three areas which is of interest to you. Because what is the most important for a digital twin? It's basically the foundational data. The data has to be clean. The fidelity of data is very important. Data is the most important thing. So we're a data first company. And then once the data fabric is very well established, the mesh is there, we are able to provide the data on demand, either on an on-prem or on a private cloud or on public cloud, keeping in mind the data security and the platform security. And then we build an intelligent expert system centered around large language models on AI. So we as a company are focused on data first, cloud first, and AI first. That's the reason why I think we complement each other very well, and we are able to target the needs of the uh, utilities in North America.
Great, great. So bringing everything together, Subhash,
Yep.
the trick, quote unquote, the trick to reimagining grid efficiency and sustainability via digital twins. T, it's important to be able to think in systems, right? Um, how are you able to connect systems of record to developing system of intelligence? And how do you use Gen AI and other ways to be able to create newer, faster, efficient systems of engagement? Very, very important. And being able to choose solutions that provide a no vendor lock-in and open architecture philosophy is crucial to be able to further the reimagining process. Resiliency and asset optimization is another key trend that we are seeing to be able to enhance the utility resiliency for a solid asset performance management. I, with digital twins, you can help increase the reliability by formalizing and integrating models, domain knowledge, compute along with big data, right? For various types of power grid and critical utility assets. You spoke a lot about this when you were talking about the business trends and the business drivers, but capital planning and predictive maintenance to have the single pane of glass, this consolidated single pane of glass, is another critical use case for digital twins. And putting it all together, you spoke about you know Encora's strong footprint when it comes to AI, but combining knowledge graph with Gen AI so that there is less hallucination with your Gen AI algorithms is, in my opinion, key to being able to improve, an energy transition and sustainability. So reducing capital and operational expenditures, increasing efficiencies are all key. So maybe I'll pause here to see if there are any questions from the audience. Subhash, do you see any? Maybe Madhura has some.
Yeah, I'm not seeing any question trickle in. Looking forward. I hope whoever has joined the call today got benefited out of the discussion we had. And Keshav comes with close to 100 plus digital twin implementation experience across industries and has been specifically focusing on the electric transmission distribution, gas transmission distribution, and oil and gas industry really well, and is a thought leader in that particular space. And there are several successful implementation. Encora has been partnering with Altair to focus on harnessing the power of digital twin for the benefit of our customers. Hi, Madhura.
Hi. Hi, Subhash. Keshav, that was amazing. Those were really good insights. And we do actually have some questions from the audience. So we're going to present them on the screen. This is the first one. It says, what training is typically needed for staff to effectively use digital twin technology?
Okay. Wow. Well, thanks for the question. Actually, I came prepared for that question, believe it or not, because I have been through similar presentations before, and usually, people ask, "What can I do now? What can I do next?" Right? So there are some really simple things, Madhura, that the audience can follow. First of all, there is a free certification program that we have for data science. So, and we can obviously send this link as a follow-up to the person who asked the question, but also to all the attendees. So you can essentially go through a self-paced, self-service, personal-based learning. But beyond this, both with Encora and Altair, we also have a center of excellence process that can really help you go from, I really don't know how to use digital twin and AI, to being able to run a lot of pilots and deploy that in production environments. In fact, we have, together with Encora, we've already done some COE exercises with a few customers to go from planning and developing the business case all the way down to implementation. And so we have the framework, if you will, broken it down to logical chunks, in addition to the training that I spoke about, the Rapid Miner certification program. I hope that answers the question.
Yeah, I think that was a pretty descriptive answer, and the visuals really helped understand the breakdown. We have a second question. It says, what's the typical timeline for implementing a digital twin in context of grids?
Yeah, see, it's a loaded question. See, there are several parameters. A typical time to build a digital twin, for example, say an electric utility, can vary significantly depending upon few factors. Most important thing which Keshav touched upon is the data availability and the fidelity or quality of data from sensors, data systems, and other sources. And Altair has got a system to process and mine the data and make it. But the data has to be clean, should be there. You can stitch in with synthetic data. That's one thing. Second thing is the scope and complexity. How many parameters do you want to take? Because the physics-based model depends on engineering parameters you want to monitor to build the digital twin. So scope and complexity of a utility network, because electric utility has got so many components. If you take a substation, the substation has got more than 1,630 components. Don't ask me where the 30 came from, but it's number of components in a substation. And the technology tools. And the technology tools, the Altair One platform is really robust. It doesn't take much time to build, but I'll not beat around the bush. If it's going to be a simple digital twin for, say, a single substation, we're looking at something like month to month and a half to few months. Again, depends on the parameters. If it's going to be 5-6 parameters, we can build it within for 30 to 45 days where the data is clean. If it's a complex digital twin where you have the entire network, that can probably take years to build. So it has to be done on a phased manner depending upon the complexity, the criticality of the electric infrastructure that's in place. So can vary from anywhere within a few months to year and a half is the answer.
I think that's great. And I think there's one more question. It says, how do you ensure interoperability between digital twins and existing systems?
Yeah, I can answer that. I think I covered parts of it in my presentation already, but the key is to have an environment that can work well with various types of enterprise data stores. So from, let's say, various types of CAD repositories, from SolidWorks to CATIA to Unigraphics and ProE, to being able to connect to various PLM systems, be it ProE, rather PTC Windchill, to Teamcenter, to Innovia, to various types of requirements management tools, through IBM Doors, JAMA, and some of the other tools, all the way down to having connectivity to big data and Hadoop type of services and various cloud vendors. I think the key is to select a platform that's nimble, that can work well with multiple types of data sources and still provide insight without you having to switch between tools or switch between interfaces. So interoperability and open architecture go hand in glove. There are obviously various types of standards that communities have built up over time. And so we also, for instance, are compliant to certain tool independent standards, such as functional mockup interface or FMI, for instance, on the modeling side. But there are other standards too that we adhere to. I hope that helps.
Yes, yes. Thank you, Keshav. Oh, and there's one more actually. Are utilities enterprises hesitating in adopting digital twins? And if yes, why? And how do they overcome the resistance?
Yeah, see, thing is, there is a perception that building a digital twin is expensive. There's a high upfront investment cost. And as I said earlier, it's an yes and no because it depends on the size and complexity. If it's going to be a simpler system, it's not going to be expensive. And I also talked about the data challenges. Utilities often have vast amount of data from various sources, right? From AMI meters to SCADA systems and all these things. And several utilities I have dealt with, I'm talking about large utilities, still have data in silos, incomplete or it's inconsistent. So cleaning of the data, organizing, standardizing data is and making it usable. That's a challenge. So that's why utilities um, don't they hesitate. Keshav and myself have met with one customer. I don't want to name the customer. It's an East Coast cybersecurity, and because they're closer to Washington D.C., cybersecurity is a major concern because they connect operation technology with IT, and utilities are very, very sensitive to data security. And we are also, even if a utility is lax in security, we basically say, hey, we need to put this security. Cyber security is one concern, so they have to go to cyber security team. They have to approve whether they can work with this particular vendor and this system integration partner. That's a concern. The last one is the age-old problem, organization resistance. People think that their job is going to be dislodged, they're going to lose their job. The digital twin, implementing a digital twin often requires changes in process, workflow will change, and people will become obsolete. It's not true. So, resistance can be managed through organization change management, and then basically can take away the issue. And then people don't see the ROI. They look at short term. This thing, it takes at least 6 months for you to see a value getting out of it. So organization believe there's a no proven ROI. So my suggestion is start small and scale. Priorities on data quality. Be focused on addressing cybersecurity proactively. Foster a culture of change, demonstrate value by working with me and Keshav through doing pilot projects, work with the expert company who has got functional domain knowledge expertise. You got an evangelist within the company who basically can work with somebody like Altair and Encora. That's another thing. And then seek senior management support. So I think those are all the things which you can do to overcome challenges.
I can just add a comment, Madhura. For me, digital twin is as much a technology initiative as much as it's a behavior psychology initiative. I think it's very important to understand and empathize and logically take the organization forward. So behavior psychology is as important as enabling new technology.
Absolutely.
Absolutely. And those are really good inputs in talking about change management and dealing with resistance, internal resistance. So thank you. I really appreciate that. I'm going to see if we have more questions. No, I don't think we do. So That's a good wrap up. Unless you guys have more comments, we can wrap the session up.
So very grateful for everyone's time and for the opportunity. Really appreciate it. Thank you, everyone.
Thank you,
Thank,
Keshav. It was nice talking to you. Thanks, Madhura, for hosting us. Much
thank,
appreciated.
thank you, thank you, Subhash. We really appreciate you taking the time, and thank you for the audience for participating in Encora chats. For more information, please visit our websites altair.com and encora.com. Thank you.
Thank you. Have a nice day.